Hello everyone. Let me proud to introduce the webinar by Magic, Cameo Inter-Op Model Migration from Rational System Architect and Rhapsody. Webinar will be delivered by Valerie Ho. She is product manager at Sodius with more than 12 years of experience in software development. As a product manager, she is responsible for Cameo Inter-Op and Cameo Workbench products since 2011. Valerie has a large experience in model-driven engineering, working on model transformation, model migration, custom code generation, and automated document production from models. She also participates in large projects for government defense agencies focused primarily on defense architecture, DoD, exchange, and conversion. Cameo Inter-Op provides customers both with import and export functionality between MagicDraw and IBM Rational Rhapsody and System Architect. Cameo Inter-Op supports both semantic and diagrams, ensuring data integrity is maintained between MagicDraw and these products. The session will demonstrate interoperability between MagicDraw and IBM Rational Rhapsody, interoperability between MagicDraw and IBM Rational System Architects, and customer experience from CACI. So Valerie, stage is yours.
Here we are focused on the four bridges, which are the conversion from Rhapsody. From Rhapsody to MagicDraw and from MagicDraw to Rhapsody. We also have interoperability between System Architect to MagicDraw and also MagicDraw to System Architect. And at the end of my presentation, I would like to do a focus on our customer experience and principally with CACI, which is using the bridge. So what is Cameo Inter-Op? Cameo Inter-Op provides the capability to exchange data between MagicDraw and other tools. Using Cameo Inter-Op, you can exchange model between MagicDraw and IBM Rational Rhapsody, and also MagicDraw and IBM Rational System Architect. Something that you must know is that Cameo Inter-Op is an open environment. You can, it's possible to use Cameo Workbench. So I will do in December another webinar on Cameo Workbench, and this tool can provide you the ability to create your own bridge. So what is exactly Cameo Inter-Op? You can do import into MagicDraw, and you can export from MagicDraw. Here, concerning import into MagicDraw, we can see Cameo Inter-Op like an engine, and it connects to the modelization tool using the COM API, using some XML file, or using some text file from the source tool. So it is in order to read data. Cameo Inter-Op will do the conversion using transformation rules, and also Cameo Inter-Op will create the UML 2.1 model in MagicDraw format. So you are dealing with MD XML or MD zip files. When you export from MagicDraw, it is nearly the same. It is the same principle. Which means that you are reading the MagicDraw file, you are reading the MDZip or the MDXML file, and you convert the data using the transformation rules. And after, at the end, you write data in the modelization tool using using the connection, using the API, the COM API, or you can also create some text files, or you can create some XML files. So there is currently a set of existing bridge. You have import into MagicDraw. So there is some Rhapsody to MagicDraw, and there is some System Architect 1.5 to MagicDraw UPDM 2.0. You can also export from MagicDraw. So there is 4 bridges. So you have the export from Cameo Data Modeler to Erin. You have the Cameo Data Modeler to Infosphere Data Architect. You also have the MagicDraw to Cameo Data Modeler, the MagicDraw to Rhapsody, and the MagicDraw UPDM 2.0 to System Architect DAF 1.5. So now let's focus on the interoperability between MagicDraw and Rhapsody. So the transformation from Rhapsody to MagicDraw will transform a Rhapsody model to a MagicDraw model, including the graphical information. So what we do when we transform from Rhapsody to MagicDraw, so we connect to Rhapsody using the Rational XMI toolkit, which use the COM API, so in order to read the semantic information. In the second part, we connect to Rhapsody using the COM API in order to read the graphical information. We then convert the data using the transformation rules. So here we have transformation from Rhapsody to UML 2.1. And after we create the UML 2.1 model in the MagicDraw format. So the most important feature of this bridge is that we can connect to the current Rhapsody project, or we can import from a Rhapsody XMI file. The interest is that when you have already exported your Rhapsody, you don't need to have your Rhapsody project open into Rhapsody, except if you want to have the graphical information. You can select you can do a selection of the Rhapsody unit to import it to MagicDraw. You can, for example, only import one package or one class, etc. And also the mapping of the Rhapsody SysML profile to the MagicDraw SysML profile is done. So now I would like to do a demo to show you how this is working. So I've prepared some video and I will show you them. So here we are in Rhapsody. So I'm showing you. It is a sample, the SysML onset sample from Rhapsody. So here you can see that we have some requirements. We have some use cases. So we have a lot of flows, links. We have subsystem, etc., etc. So it is a SysML model, so you can see there is some blocks. There is some blocks. If we have a look in the diagram views, we also have some diagrams. So here you have a requirement diagram. We have here a use case diagram. We can show also some block definition diagrams. And we have also internal block diagrams. So as we have here another internal block diagrams and an activity diagram. So the tool here is Cameo Inter-Op. It is a window with the services that are available. So here we are launching the Rhapsody to MagicDraw service. So it takes in input the Rhapsody model. So as I said, you can connect to the current Rhapsody project. You can also import from an XMI file already exported. So here we are connecting to the Rhapsody project. here we are selecting our MagicDraw output model. And we click Finish, so the transformation is running. Here we are exporting the model, we are reading some profiles, etc. We are analyzing the Rhapsody diagrams. We are transforming, and the transformation is done. So now if we check the result into MagicDraw, you can see that we recover the elements into MagicDraw, the semantic elements. So we have here the same requirements. We can see that there is some use cases. We recover the architecture package. We recover the same elements. And graphically, you can see that we have created some activity diagrams. So here is the activity diagram I show you into Rhapsody. So we can compare from Rhapsody in the left and into MagicDraw in right. Here you can see some packages, some class diagrams. So this is the result of our transformation. Here we have our requirement diagrams. So we can also compare the result from our input model. So we recreate the sequence diagrams also. The state machine diagrams. Our high-level architecture, which is a block definition diagram. Our internal block diagrams. So here we can also compare from Rhapsody. And here we have our use case diagram. So this is for the first transformation, the first migration. Now we can continue with our MagicDraw to Rhapsody transformation. So it is possible to import the data from MagicDraw to Rhapsody, including graphical information, of course. So what we do is we read the MagicDraw file, we convert the data using the transformation rule, and we connect to Rhapsody using the Rhapsody XML toolkit, so using the COM API, in order to write the semantic and the graphic information. So the main feature are that we can connect to the current Rhapsody projects. We can do also a selection of the Rhapsody unit to import it to Rhapsody. And also the mapping of the MagicDraw XML profile to the Rhapsody profile is done. I want to show you also how it is working. So let's continue with another example of the transformation. Oh, sorry. Let's, okay, so now we are into MagicDraw, and we have a XML model, and we can see that we have here some use cases. We have for example, here a sequence diagram. We have here another activity diagram. we can see that we have some structure and some block definition diagram. Here you have a block definition diagram, so it is a XML diagram. And here we have a package diagram. So we have a set of diagrams and a set of elements. Here we have a state machine diagram. And a use case diagram. So the principle is the same. Here we have Cameo Inter-Op, and we want to run the MagicDraw to Rhapsody service. So we select the input MagicDraw model. So we have a connection to the current Rhapsody model, the current Rhapsody project. So you have to have a Rhapsody running with projects. So now it is reading the MagicDraw model. So it is analyzing the MagicDraw diagrams, analyzing the MagicDraw UML model, and it is importing it to Rhapsody. And now the export is complete. So we can check our result into Rhapsody. We have the same hierarchy of element, and we have our package diagram there. So we can compare with what we have into a MagicDraw. So we recover globally the graphical information. So we have the creation of some blocks. Here we should open our block definition diagram. So in MagicDraw it was that. Let's open our state machine diagram. So we can compare also with our MagicDraw diagram. We can check also our use case diagram. And here we have our activity diagram. And here we have the sequence diagram. Oh, okay. So let's continue with our presentation. Now I would like to present you the interoperability between MagicDraw and System Architect. So our System Architect to MagicDraw transformation will transform a System Architect DODAF 1.5 encyclopedia to a MagicDraw UPDM 2.0 model, including graphical information. So what we do here, we connect to the System Architect tool to read the semantic information and the graphical information. We use the bridge, the Cameo Inter-Op bridge, to transform the model, the system architect model, to create a UML 2.1 model in MagicDraw format. So we write MD.XML or MD.zip file. So the main features are that we can connect to the current system architect encyclopedia or to a selection of system architect XML file. We can do a selection of the diagram to import. We can generate a traceability report, so I will talk about that later. We can do the creation of non-standard DODAF elements, so I will talk about that also. And we can import the Excel SV matrices from System Architect. So here are the lists of diagrams that we can export from System Architect. So we can export the all view diagrams AV1 and AV2, the capability views CV2, CV3, CV4, CV6 and CV7, the data and information view div1, div2 and div3, the operational views OV2, OV3, OV4, OV5A, OV5B, OV6A, which is mapped to a MagicDraw OV6B, and OV6C. Project view PV1, service view SVCV1, SVCV3A, and SVCV9. The system view 1.4A, 4B, 5, 5A, 5B, 6, 7, 10B and 10C, and also the technical standard view, standard V1. So now let's do a demo of the System Architect to MagicDraw DODAF transformation. So here we can see that we are in System Architect. So I'm using the DODAF sample from System Architect. So here we have an OV1 view. We have also an OV2 view. We have a connection relation between operational activities and operational node. We have an OV4 view. We have two OV5 views. Also, as I already said, we don't have the example in the DODAF sample encyclopedia, but it is possible also to transform the BPMN diagrams from System Architect. So here we have an OV7 view, SV1 views, here we have SV2 views. We have the SV4 data flow views. The SV4 functional decomposition views and the SV11 views. So like for the previous transformations, we have a service called System Architect to MagicDraw that we can run from Cameo Inter-Op. So what we can do here is it is possible to connect to the current encyclopedia. So it means to connect to the current System Architect, the current encyclopedia running into System Architect. Or it is possible to select an XML file from System Architect. Here we have the possibility to select the diagram we want to import into MagicDraw. So In my example, I will import the complete encyclopedia, but it is possible to select one or several diagrams. We have some other options I will explain later. And here we can export Excel SV matrices. I will explain also that after. So here I click finish, so I'm running the service, so it is reading the model, the encyclopedia to system architect, and it is converting the system architect elements, writing diagrams, reading some MagicDraw profiles in order to create the proper MagicDraw file. So if we check our result into MagicDraw, so we can see that we have the information into MagicDraw. So here we have the data information. We have the operational views, some operational nodes, some org units, some activities. We have also the service, the system views created. The systems, etc. So if we check our diagrams, here we can see that we have our div2 diagram which is recreated, comparing from system architect. So we recover the semantic elements and the graphics. We have the div3 diagrams, the corresponding div3 diagrams. We have the OV2 diagrams, and we have the link between the performers and the operational activities. We have the OV4 decomposition. We recover the OV5A diagrams and the B1s also. So the operational activities. We recover the state diagrams. So this system, the SV1 diagrams, here we have an SV2 diagram, and the last diagrams, which are SV4 diagrams. The functionality description. And the last transformation conversion I would like to present is the MagicDraw to system architect transformation. So this one transforms a MagicDraw PDM2 model to a system architect 1.5 encyclopedia, including graphical information. So what we do is we read the MagicDraw file, so again an MD-zip or an MD-XML file. We convert the data using a transformation rules, and we connect to the system architect to write the semantic and the graphical information into the tool. The main features are a connection to the current System Architect encyclopedia or a selection of System Architect XML file. You can select the diagram you want to import into System Architect, and the list of diagrams that are exported from MagicDraw are the data information view div2 and div3, the operational view, OV2, OV3 report, OV4, OV5A, OV5B, OV6B, and OV6C. And the system view are SV1, SV2, SV4A, SV4B, SV5 report, SV10B, and SV10C. So I would like to show you also how it works. So here I have a video on the transformation from MagicDraw to System Architect. So here we are in MagicDraw. So it is the DODAF sample from MagicDraw. I have a set of elements, so capability views, some capabilities. I have some data and information views. I have also some operational views, so I have an operational node, etc., etc. Some OV4, OV5A, systems. So to show you some diagrams, here I have an OV2 diagram, also with some performance and operational exchange between them. The named lines. So OV4, OV5A. So here I have a BPMN diagram. So an OV6B, an SV1 diagram, so system and exchange between them. So if I run the transformation, so again, it is a service that transforms from MagicDraw to System Architect. So I select the MagicDraw model I want to transform. Here I have two types of connection: current encyclopedia, so the current encyclopedia open in System Architect. Or I can also create an XML file to be imported right afterwards into System Architect. If I click Finish, so I'm reading the MagicDraw MD-zip file. I'm running the transformation and I'm creating the element into System Architect. Once the transformation is done, you can check your result into System Architect. So here I have the div2 from MagicDraw. We can compare with the MagicDraw one. So we recreate, by default, we recreate some semantic decomposition diagrams. Here we have the OV4 diagrams. So the OV6B diagram, the OV6C diagram recreated, the OV2 diagram, the OV5 diagrams with the semantic decompositions. Here we have the BPMN, so we are quite constrained with the graphics of System Architect. The MagicDraw configuration, the maritime configuration diagram, the SV4 data flow diagrams, the SV1 diagrams. Here we can compare, for example, the state transition diagrams. Now, to conclude my presentation, I would like to do a brief, to present you our customer experience from CACI. So what need CACI? They needed to do a migration of a set of System Architect DODAF 1.5 XML files. So they had several System Architect XML files. And the files were provided by one of their customers. And what we've done in order to be able to import their XML file, we've created a service that takes several System Architect XML files to create only one System Architect file and to be able to transform this big one System Architect file into a big one MagicDraw file. We've developed some option for the conversion of standard and not standard definitions. We've also developed a generation of traceability reports. We have exported some information from the SV matrix they had from their customer. What means exactly our System Architect XML merge? It is a service that can be used directly from Cameo Inter-Op that takes several XML files to create only one. So it takes one directory as an input, and it creates an XML file that can be used, for example, by the System Architect to MagicDraw transformation. Also, what we've done is we've developed our transformation in order to take into account some additional properties. When you have some additional properties added to the standard DODAF definition in the encyclopedia, they were ignored by default during the transformation. And what we've done is we've done some transformation to be able to take into account these elements. So we have the creation of a profile called essay profile. With stereotypes the additional elements, and we have exported their properties, the System Architect properties, as a tagged value of the stereotypes. So here we can see that we have a data store which is called field order archive, that is a stereotype ESA data store, and it has a tag value which is normalized, and this information wasn't taken into account by default by our transformation. Also, we have another conversion. It is the conversion of the non-standard definition. They were ignored by default during the transformation. And when we use the option, the custom definition can be imported into MagicDraw using stereotyped classes. So what we do, we create a profile called essay profile. The elements are exported into a SA elements package, so the additional elements that are not taken into account at all by the transformation. And these additional elements are stereotype. And the system architect properties can be exported also as tagged value of the stereotype. So here, for example, we have a SA element which is a communication connection. It has been stereotyped SA communication connections. And these communications connections are not taken into account by our transformation. Also, we have a generation of traceability reports. So it is possible to have a report on the transformed element on how they have been transformed. So there is three kinds of information that we generate according to the option of the traceability. So we have the DORDAV standard elements, for example, operational nodes, system components, system elements. And we have the customed elements. So for example, I have here a bottom ranked, an element called bottom ranked, which is SA analytic. And it has been stereotyped SA analytic, for example. And we have the inured elements. So for example, I have an asset which is called Apache, which is inured by the transformation. And the last big option we have, the last big point big feature we have added to the transformation is a post-process to MagicDraw model created by the system architect to MagicDraw transformation. So there is three kinds of SV metrics that we can import. The SV5A, so we will create a relation implements between the system function and the operational activity. The SV5B will create a relation performed from the system to the operational activity. Of course, I said it will create if it is not already created by the transformation, because a perform relation from a system to an operational activity is normally taken into account by our transformation. And SV6 matrix will import three kinds of information. It will create the non-existing interface, it will create the non-existing exchange element, and it will add the realized exchange relation between network connection and interface. And I think this is the end of my presentation.